What's up? Check it, check it, check it, check it. Okay, this video deals with talk about percent composition of different things. But before we get there, the question is, well, what is percent? So, a quick review. So, percent basically is part over whole times 100. We can talk about taking a test. You get 80 questions out of 100 questions correct. The part is the 80, the whole is the 100. So 80 divided by 100 times 100 gives us 80%. Okay, so here's another example right here. We got Jack Be Quick plays soccer. Yes, there is a joke in that name, if you're wondering. If he scores 8 goals out of 10 tries, that's an attempt, okay? Or a shot, if you will. What is his percentage of success? Well, we said that the percent is part divided by, that's why you see the line there, the whole times 100. Okay, so 8 divided by 10 is 0.8 times 100 means 80% success. Jack Be Quick has a future. Yeah, okay, we keep telling ourselves that. Now, how does this apply to chem? Well, if you think about it, in chemistry, percent composition in any compound can make a difference in whether the compound works the way it's supposed to or not. So one example here is the theory of the Titanic was that the steel plates on the ship had too much sulfur in it, and thus the plates broke when the ship hit the iceberg. We found out that this was not true at all. They theorized there was too much sulfur in the makeup of the steel plates, sulfur impurities, and that with the cold temperature, those plates broke, they shattered, and by going underwater and checking it out, they found that's not true at all. It isn't. So that is a real life thing about percent composition. When people sit there and say, when are we ever going to use this? Well, think another real life example. What about medication that you're taking? That would be important to have the right percent composition of the stuff that you're taking. You don't want the medication to be too weak because that won't help you. If it's too strong, that can hurt you. So, that's chemistry in the real world. Deal with it. All right. So we got a problem that we're going to work on. Find the percent composition of the following. Fe2O3, rust. Interestingly enough, that is on your packet. So let's go with it. So there's some few steps that we're going to have here. Find the percent composition of the following. Fe2O3, rust. Well, wait a minute. What do you mean by percent composition? Well, by the mass, how much percentage of this bit of rust is iron by weight? And what's the percentage of the oxygen by weight? That is percent composition. Okay? It's kind of like how much, talent does a person have in playing a certain sport? If they're really good at it, their composition is they have a greater percentage of talent compared to no talent. Okay, not the best example. So let's go with it. So step number 1, we assume 1 mole of the sample. Why in the world would we do that? It actually makes the calculations a lot easier. Now what do we know about Fe2O3? We have 2 irons and 3 oxygens. Okay, so then step 2. We need to calculate how many grams there are in a mole of the compound that we're working on. Now in our case it's Fe2O3. So Fe, that's our iron, is equal to 2 times 55.85, which equals 111.7 grams. You might want to work that example on your packet while you're at it. Packet, at it, check it, I rhymed! All right, the other one is oxygen. That's equal to 3, because we had 3 oxygens, times 16.00 gives us 48 grams. Now, of course, inevitably, somebody is going to ask the question, where did we get the 55.85 for the iron and the 16.00 for the oxygen? The periodic table. That's where we got it from. Okay? We did make it up just out of thin air, unlike government numbers. Okay, now step number 3. Whoops. Here, let's bring that down here. So step number 3, we add up the total grams for all of the parts of the compound. So that's what we did here. We figured this out in step 2. We added it up, and we know that there's 159.70 grams per mole. That's what we have to look at. Okay, so that is our whole, ladies and gentlemen. That is our whole. Step 4. Find the percent of the part. You divide the grams of the part by the grams per mole. In other words, you're going to take your part and divide it by the whole. So in the case of the percent of iron, we have 111.7 grams. That's what we figured up here. Okay, divided by the 159.7 grams per mole. We figured that here, and that gets us 0.699. Now, is the 0.699 a percent in and of itself? No, it's not. Okay, it's a decimal, so we have to multiply by 100 to get 69.9% iron. That's what we have. So right now, if we look at our composition of Fe2O3, 69.9% of it is made up of iron. Now, what about the oxygen? Well, we got 48 grams. We figured that out up here, right? Remember that 16 came from the periodic table. 48 divided by 159.7. We got that number by adding this up for the grams per mole. So we took the part, the 48, divided by the whole, the 159.7. And that gets us 0.301. Again, is that our final answer? No, that's our decimal. We have to multiply by 100. Now, some people would say, well, wait, Mr. Canu, couldn't you just simply move the decimal to the right 2 places? Yes, yes, you could. Well, why are you saying you have to multiply 1 by 100? For some people, they need to know that. For other people, they know, okay, I got to move the decimal place 2 places to the right. It's whatever floats your boat, yo! That's what it's all about. So, I put it in red. What is the answer? Our answer, ladies and gentlemen, is 69.9% iron, 30.1% oxygen by mass. That's the composition. Okay? So that's what it is. And in this case here, if you add up the percentages, check it, check it, check it, you got 100. Yeah, 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 you got 100. That's how it works out. Okay? All right. Any questions? You're watching a video. You can't ask. Ha! Ah! Ah! Now, let's see if we can do some real calculations. Oh, hey, this thing lasted about 10 minutes. Good. All right, let's try another one. Okay? Let's look at good old water. What is the percent of oxygen and what's the percent of hydrogen? Now, some people would say, Mr. Canu, I'm still confused about the percentages. Well, let's think about this. When you go shopping for something and the stores offer a discount sale, and let's be honest, ladies and gentlemen, any mall you go to, whether indoor or outdoor, practically all the stores will put the 30% off, 50% off, up to 90% off, those types of discounts. And that's kind of important for you to know about the discounts, because that way you know how much you are, quote unquote, saving. Okay? So you need to understand that. So we're doing the same thing here. So the techniques here, this is not some mysterious, Illuminati cult of chemistry. No, it's not. Percentage is a real world skill, yo. That's how it works. Yeah, it is. So let's go with it. So here's our hydrogen, hydrogen and our oxygen. Where do I start? Well, okay, I know that I have got 1.01 grams per mole of hydrogen, and I'm going to multiply that by 2. And where did I get the 1.01? Our periodic table, so 2.02. Okay, then we have our oxygen. Well, that's 16.00 grams per mole times 1, that's equal to 16.00. Again, where did I get that? The periodic table. I add those up, I get 18.02 grams per mole. So that's what we have. So wait, Canu, I'm not sure what you did. No problem. Let's go with this. If we say that the percent is the part over the whole, okay? That's the whole point. When we sit there and say, oh, the album from my favorite artist is like 30% off, okay, what does that mean? Well, if the normal price of the album is $20, and we're talking CD, not this download stuff. You got a physical CD for this, okay? And you had 30% off, okay? Well, what's 30% of 20? Well, in this case, you get to multiply it, and you find out 30 times 20, 30%. That's really a 0.3 if you think about it. Times 20 is 6, so it's $6 off, which means instead of paying 20 bucks, you pay $14 instead of the 20. Am I saving money? Yeah, I'm actually saving a little bit of money that I'm going to go and spend it on something else that may be, cool or not. So let's look at this. So if we're saying that the percent is part over the whole, well, let's look at the percent of hydrogen. Well, what is the whole? The whole is the 18.02. That, ladies and gentlemen, is the whole, because that's how many grams there are in a mole of water. Because we're assuming 1 mole of water. You got to see what a mole of water looked like last week or the week before. Okay, now what's our part? Well, our part for the hydrogen is 2.02. So this is the part that was our hydrogen. This is the part of the water. The part of the hydrogen, that's the part. The water itself is the whole. So, quick thing here, what do I have? 2.02 divided by 18.02, and I come out with 0.1121. I'm going to go with 3 significant figures on this one, so I'm just going to say 0.112. Okay, and I'm going to multiply that, because that's not my percent, that's my decimal. So I'll multiply it by 100, and I'm going to walk away with 11.2% hydrogen. Okay? So that's what we have for our hydrogen. Now the question is, what's the percent of oxygen? So we got our hydrogen, yippee. What about our percent of oxygen? Well, there's actually a couple of ways you can do this. One way is, because you only have hydrogen and oxygen, here's a fast way. We know that water is 100%, right? That's the water. If we take away the percent that's hydrogen, and that's going to give us the percent of oxygen. Think about it. All right? Now, in this case, the 11.2%, that's all the hydrogen. So if you want to look at it that way, that it's like an H2, That works. That will do it. Okay? So we can do that. And let's see. That would be 88. Well, I'm going to go do it on the calculator here. So 100 minus 11.2 equals, and I got 88.8% oxygen. Now that's one way to do it, okay? That is the short and quick way. And it only works because you only got two pieces. You only got the hydrogen and the oxygen. But what happens if you have more than two pieces? Then, ladies and gentlemen, that's when you have to go and do a little bit more work. Okay? So for this, in our case, here, guys, let's look at the regular way for oxygen. So for percent oxygen, so I'm showing you two ways. The first way was quick and easy, okay? And that doesn't, you don't always get that. So for the oxygen here, well, let's see. What do we know about the oxygen? We know it's third H2O, so that's going to be 16.00 grams, okay, over 18.02 grams per mole. Where did I get the numbers? This is from the periodic table for oxygen, and this is how many grams there are in 1 mole of water. So we're taking the part divided by the whole. That's our key thing about percent. Okay, if I'm a store owner and I want to sell something, okay, and I sell something normally for $20, that's my whole, okay, and let's say I want to charge, you know, $18 for it. Okay, so 18 over 20 times 100, and that will tell me how much of a percent I have off. The percent off sale. Here we're looking at 16 divided by 18.02, so 16 divided by 18.02. And I have here 0.8879. Is that the final answer for the oxygen? No, it's not. We're sticking with 3 significant digits for this. So we're just going to go ahead and say 0.888. Okay, now 0.888 multiplied by 100 equals 88.8%. That's it. Let's check. Is it close? Yeah, it worked out with us. Now sometimes it might not. Sometimes it might be off by 0.01 or 0.1%. Generally speaking, it should be really close when you add them up. Should be really close to 100. Okay? So that is it for percent composition. Okay? Hope you enjoyed that. And well, okay. Some of you guys are saying, no, it's not. And yet you use the percent when you're trying to figure out the discounts. Okay? Which you realize those retail clothing stores, they already jack up the prices when they first get those clothing items. Then they sit there and they do the discount. Those guys are still making money, even if they slash it over 50%. I'm just saying, don't hate the player, hate the game, yo. Alright, until next time. You thought I was going to freak you out, didn't you?